In the previous class, we have derived a relation of the parameters. Actually, we mainly derive a equation by using which we can calculate some parameters of a unit cell. Okay, or we can even calculate the density of a solid, or the number of atoms which are present in that solid can also be calculated. Okay, always remember that the concept of a topic or a subject can be cleared by only doing some problems. Okay, so if you can do some, or if you can solve some problems related to that topics, then only your concept will be clear. So today our objective is to do some numerical problems related to that equation which is derived in the previous class. Okay, the first example is the example 1.3. okay, so all the examples are taken from your NCERT book. Okay, so in this example the question is actually an element has a body centered cubic structure with a cell age of 288 picometer. The density of the element is 7.2 gram per centimeter cube. How many atoms are present in 208 gram of the element? Okay, so when we are trying to solve some numerical problems, always remember that we have to write first the given things. Okay, so here what is given? So given that the unit or the solid is actually formed by BCC unit cell. So this is the first information. Okay, so in case of BCC unit cell, we know that the number of atoms in one unit cell is equal to 2. We already know this one. Okay, and here also the cell age or the age length of the cell is given, and the age length of this is we actually represent it by small n, so is equal to 288 picometer. Okay, so always remember that we have to convert this unit into SI unit and CGS unit. Okay, so here in this case 288 into 10 to the power minus 12 meter, and is equal to actually 288 into 10 to the power minus 10 centimeter. Okay, density of this one is equal to is given, and it is what, 7.2 gram. So what we have to calculate? We have to calculate the number of atoms present in 208 gram of the elements. So let us understand the problem. Okay, so let's suppose this is the solid. Okay, suppose this is the piece of the solid. Okay, suppose. Okay, so and here it is already given that the entire solid is formed by only BCC unit cells. Okay, so that means there will be many BCC unit cells present inside this solid. Okay, so let's suppose this small cube represent one BCC unit cell. Okay, so our aim is what? Our aim is to calculate the number of atoms present in this entire solid. Okay, and it is given that the mass of the entire solid, that is the element, is what, 208 gram. Okay, so this is actually the mass of entire solid. Okay, this whole solid. And here we already know that this is a BCC unit cell. That means all the unit cell present inside this solid is BCC unit cell. So the number of atoms which are present inside one unit cell is equal to 2. Understand why it is 2? Because in case of BCC unit cell, we know that the number of atoms present inside that unit cell is equal to 2. So actually our aim is to calculate the total number of atoms present inside this solid. So how we will going to calculate the number of atoms actually? So if we calculate the number of unit cells present inside that solid, then we can also calculate the number of atoms present inside that solid. You see, here we know that the number of atoms which are present inside one unit cell is equal to 2. So if we can calculate the number of unit cells, okay, present inside this solid, then we have to multiply the number of unit cell by 2 only. Then we can get the number of atoms present inside that solid. Understand, no? So we can solve this problem by actually calculating first the number of unit cell present inside this solid. Okay, again we already know that the value of A is equal to given as what? A is given as 288 into 10 to the power minus 10 centimeter. Okay, so that means what will be the value of A cube? So A cube value will be 288 into 10 to the power minus 10 cube centimeter cube. Okay, so this is the value of what? This is the value of the volume of one unit cell. Again, if you look at this figure, then here you see here the mass of this whole entire solid is given. It is as 208 gram. Okay, and also the density of the solid is given. So we know that in case of crystalline solid, the density of each and every portion is equal, because the arrangement of the constituent particles are ordered way. Okay, the arrangement of the constituent particles are ordered, so density is uniform. Okay, so then the density is given as well 7.2 gram per centimeter cube. Okay, so what will be the volume of this solid? So the volume of the given solid sample, given solid sample, that means whole solid, okay, is equal to what? Is equal to, we know that the density is equal to what? Mass per volume. So volume is equal to what? Volume is equal to mass per density. Let's suppose this V represent the volume of this entire solid. Okay, so that means we have to write here what? The mass of entire solid divided by density of that solid. Okay, so here the volume of the given solid sample will be the mass of the entire solid, the given solid, all the solid. Okay, not mass of the only one unit cell, all the solid, because we are trying to calculate first what the volume of the given solid sample, that means the whole sample. Okay, so it will be divided by the density. Okay, density of the solid. Okay, so the mass of the given solid is what? 208 gram, and the density of that solid is what? 7.2 gram. Okay, so gram per centimeter cube. So it will be actually equal to, if you calculate this one by using some calculator, then you would get 28.88 centimeter cube. Okay, so this is the volume, because gram will cancel out, so it will go upside, so it will be, so that means this represent what? The volume of the whole solid, and the volume of this one is what? The volume of only this cube is actually A cube. Okay, that means this one, and the volume of the whole solid is this one. Understand? Clear? So if we divide the volume of this whole solid by the volume of one unit cell, then we can get the number of unit cell. Understand? So the number of unit cell will be what? Actually the number of unit cells present in the entire solid is equal to what? Is equal to, actually what we have to do? We have to divide the volume of the entire solid, okay, which is actually 28.88 centimeter cube, divided by the volume of only one unit cell. Okay, then we can calculate the number of unit cell, how many unit cells are present there. Okay, so divided by 288 into 10 to the power minus 10 3 centimeter cube. Okay, so it will be what? 12.08 into 10 to the power 23. Okay, so it will be what? Actually number of unit cell present in the entire solid. Okay, so that means we are able to get the number of unit cell present in that entire solid. So what we have to do now? So our aim is to calculate the number of atoms present in that entire solid. So we have to just multiply this number of unit cell present in the entire solid into 2, because in one unit cell 2 atoms are present. Then this number of unit cell will be the number of atoms present in this number of unit cell will be multiplied by 2. We have to multiply this number into 2. Thus the number of atoms present in that entire solid will be 2 into 12.08 into 10 power 23. Okay, so it will be equal to 24.16 into 10 to the power 23 atoms. Okay, the next question is the example 1.4, in which we have to calculate the atomic mass of copper. Okay, so the given thing is given that, so what are the given things? Here it is, they said that the entire solid is formed by FCC unit cell. So we know that in case of FCC unit, cell, okay, the number of atoms, what? The number of atoms, okay, per unit cell, that means in one unit cell, okay, unit cell is equal to 4. Okay, so this is the first given things. And the edge length of the unit cell of the FCC unit cell is equal to, it is found from what? X-ray crystallography. Okay, so they did some X-ray crystallography experiment of that solid, and they found that the edge length is equal to 3.608. okay, 3.608 into 10 to the power minus 8 centimeter, and the density of the solid is equal to it is given that 8.92 gram per centimeter cube. So we can use the formula or the relation which we have already derived, okay, in the previous class, which is density D is equal to Z, the number of atoms present in one unit cell, into the atomic mass of the atoms, or in case of molecules it is molecular mass. Okay, so capital M represent atomic mass here, okay, atomic mass of the copper, divided by Avogadro number into A cube. Okay, A cube means the volume of that unit cell. Okay, so here by using this equation we can write, or we can find out the molecular mass capital M is equal to D, that means the density, into the number of Avogadro number actually, into A cube divided by Z. So we have already the values of small d, that means density, volume, and also the number of atoms present inside that unit cell. Okay, so we have to just put the value here, because we already know the value of the Avogadro number is 6.022 into 10 power 23. So we have to just put this value here. Okay, so that means thus M is equal to, that means what M represent, what M represent your atomic mass of copper. Okay, so here the atomic mass of copper is equal to what is the value of D? The value of D is equal to 8.92 gram per centimeter cube. Okay, and we already know that the value of Avogadro number is 6.022 into 10 to the power 23. Okay, but here atoms 23 atoms per mole. Okay, per mole. So we know the value of A, so here we put the value of A, 3.608 into 10 to the power minus 8 centimeter, and we just cube this one. Okay, and for FCC unit cell we know the value of Z is equal to 4. So we have to just do simple mathematics. Okay, so by doing the mathematics or by using some calculator, we can get the value as 63.1 gram per mole. Okay, so that means the atomic mass of copper is found as what? Is equal to 63.1 U in atomic scale. Okay, so coming to the third example, in third example we have to just calculate the density of silver. Okay, and atomic mass is also given, the edge length is given. Okay, so we have to find out the density. So what are the given things in here? So this is actually example 1.5. okay, so given that the lattice or the 3D packing is what? CCP. Okay, thus the unit cell is FCC. Okay, and we know that in FCC lattice or FCC unit cell, number of atoms present in one unit cell is equal to 4. We already know this. Okay, and edge length is given. Edge length of the FCC unit cell is given, and this is what? Is equal to 408.6 picometer. Okay, so we have to convert it into what? In centimeter or meter. So we can convert it in SI unit, which is actually 408.6 into 10 to the power minus 12 meter. Okay, so this is the value of A. And the molar mass of the silver, actually atomic mass or molar mass. Okay, here actually it should be atomic mass. Okay, atomic mass, we can write atomic. Okay, atomic also, but here it is actually atomic. Okay, atomic mass of the silver is given, which is actually capital M. Okay, is equal to 107.9 U. Okay, so actually U means actually this is nothing but what? 107.9 gram per mole. Understand? So we can convert this in SI unit, which is going to give you 107.9 into 10 to the power minus 3 kg per mole. Okay, simple. So here you see, here we we convert the units into SI unit. Here also SI unit in case of A, or also the molar mass or the atomic mass of the silver is also converted into the SI unit. So even you can convert it into CGS unit, no problem. Okay, but the unit should be in the same system. Okay, here we use the SI unit system. Okay, so now we can use the formula. Okay, now we know that the formula is what? Density is equal to Z into atomic mass or molar mass of the molar mass. Okay, divided by capital N A, which is Avogadro number, into A cube. Okay, so we have to find out what? The density, which is D. Okay, this is nothing but what? Density. We know that density. So we have just put the value here. In place of the Z, we put the value 4 atoms, and in place of capital M, that means the atomic mass, we just write 107.9 Newton per minus 3 kg per mole. And here this is the value of Na, that may Avogadro number, and here the A cube. Okay, and by using mathematics we can 110.5 into 10 to the power 3 kg per meter cube. Okay, so that means the density of the solid substance, okay, that means the silver is equal to 10.5 into 10 to the power 3 kg per meter cube. Okay, so if you convert this one into gram, then it will be your 10.5 gram per centimeter cube. Okay, so there is two way. Okay, so you can directly use the CGS unit here to get the value in gram per centimeter cube. Okay, or you can use the SI units like this, and again you can convert it into CGS unit. So hope you understand these problems. These are very easy problem. Okay, so what we have to do, basically we have to use the formula which is derived in the previous class to solve these problems, and also we need to know about some basic concept of solid state chemistry to solve these problems. Okay, so in the next class we will discuss about the impurities in solids. Okay.